Hi everyone, in this recording we are going to find the sine of 255 degrees. Now while you may want to use a half angle identity to do something like this, if you already learned half angle identities, in this particular case we are going to use an angle sum or difference identity. Alright, I have sine of 255 degrees. The first thing I'm going to do is I am going to do as I always do. I'm going to default to a sum identity and I'm going to make my alpha 45 degrees. If I need alpha and beta to add to be 255 degrees, that means that beta will be 210 degrees, like that. From this point, we are going to proceed by writing out, I'm just going to switch pens here, writing out what my identity formula is. And for sine of alpha plus beta, like that right there, let's scooch that, sorry. For sine of alpha plus beta, it is the sine of alpha times the cosine of beta. Sine keeps the same sign, so if that's plus, and then we switch it around. The cosine of beta, or alpha rather, sorry, times the sine of beta, like that right there. Now, if you by accident end up getting the same answer for this and this, you messed up. They're going to be different. They're not going to be the same. Okay, so reevaluate what you're doing, double check it, because they should not be the same. Now, after you find the sine or cosine of an angle, you should no longer have the word sine or cosine written because you have performed the indicated function. For 45 degrees, sine and cosine should both be positive square root of 2 over 2. 210 degrees, get a little visual on it. It's 30 more than 180. Left a lot, down a little. The left right is your x or your cosine. A lot to the left means negative root 3 over 2. Down a little to get to that 210 would be just a little bit, down 1/2. Now all we have to do is clean up. Negative times positive means I have negative root 6 over 2 times 2 is 4. The only time we keep denominators is when you are adding or subtracting. Plus, and I'm going to have a negative here, so it will become minus. Fraction again, so that would be root 2 times 1 is root 2 over 4. Now this answer can be cleaned up and written in a number of ways. Perhaps you keep it fairly simple, negative root 6 minus root 2 over 4. Perhaps you factor the negative out and have root 6 plus root 2. Sorry, I'm squeezing that. Over 4, that's also fine. Any type of representation of this, maybe you even pull the negative in front of the fraction bar. I'm not a big fan of this because I think the negative gets lost a lot of the time, and you write it like this, but you want to make sure that whoever's reading it, whether it's you or someone else, really knows that this negative out front is out front. So it's a lot like this situation right there. It's up to you if you need parentheses around the top to make sure that that negative doesn't accidentally only be get applied to the root 6, then do it. And I hope you are feeling pretty smart about this right now, feeling good about yourself. If you are, please, by all means, feel free to give the video a thumbs up. If you don't feel good and you're still stressed out, give it a thumbs down. Hopefully we're all in a good place. Click through for the next example. Check the playlist if you want something specific. I try to make all the thumbnails pictures of the problem, and I will see you in the next one. Adios.